Welcome to Hyomoto and Julian's podcast. I'm Hyomoto.
I'm Julian.
I got to look that way to find you. All right,
Nice to meet you.
we did our last podcast on state, which is kind of a big topic. But today we're gonna branch out that a little bit, and we're gonna talk about encapsulation.
An even bigger topic, mind you.
Yes, we're starting with all the big ones. So the first piece we're going to put into here was like what encapsulation is, and Julian has prepared a mesmerizing, mind-bending speech about this. So go ahead and hit him up with that, Julian.
Um, yeah, well, basically, encapsulation is the idea in object-oriented programming that you are going to store your data in one place, which makes sense when you think about it, because let's say you have a player object. You don't want player speed to be stored in the enemy speed object or in the enemy object. That wouldn't make a lot of sense if you think about it. And
It'd be quite
well, that's
ridiculous.
basically, yeah, it's basically what encapsulation is about. It's one of the four core pillars of object-oriented programming, and we're going to talk about all these at a later date, maybe. But for now, we're going to talk about encapsulation.
Oh yeah. In fact, the encapsulation will kind of touch on a lot of these things, and so I did want to briefly cover here the differences between types of programming because not everybody may actually be familiar with this. Because you hear structured programming, object-oriented programming, functional programming. Those are the big three everybody's all hot and bothered about. But what you might think is you'd be like, how am I coding, right? Like I've often heard people kind of believe that a language is object oriented or it's functional. All languages are structural, so I did want to cover this briefly just to kind of give a primer on that. And and starting with structured programming was back before structured programming was a thing. We did abandon that. All languages are now structured, but it was you had essentially the go-to statement, and the go-to statement would allow you to go from any instruction in the program to any other instruction in the program, and that kind of violated the integrity of the program because there was no way to prove that the program worked. I mean, yes, you could run it and it could run, but you couldn't prove anything. And a lot of programming has its basis, unsurprisingly, in mathematics. Lambda calculus was considered the first programming language in the world, and math has always been obsessed with proof. Can you prove that your function works? Can you prove this outcome? And that's where structured programming came in, was in a bid to actually be able to prove mathematically that your functions did what they were supposed to and that they would produce the proper results. You had to get rid of the go-to statement. And so that is what really structured programming ends up being, is the idea that your program has to be structured. It has to exist within small blocks of code or large blocks of code that must run. They must be complete. Object-oriented programming builds on top of that by saying that by expanding that structure into its four pillars. One we'll be talking about: encapsulation, abstraction, inheritance, and polymorphism. And then the last one is functional programming. Now, object-oriented programming and functional programming are kind of at odds with one another because uh, object-oriented programming is all about mutability inside of a structure, whereas functional programming is all about immutability of state. And you might notice by those two definitions, they don't actually oppose each other. Immutability of state and encapsulation of mutability are not mutually exclusive concepts, and that's the big misconception. Is when you're programming, GML is largely a structured language, but when you're programming with objects, you're doing object-oriented programming, and depending on how you want to use some of your functions, you might even be able to get a little bit of functional programming done in there. Again, I don't want to talk too much about these in detail, so we're going to leave it at that for now and move in today's topic, which is going to be one of those pillars of object-oriented programming: encapsulation. Now, the reason why we were kind of inspired here was Eldigen in the chat had asked a question about constructors. And what are your thoughts on constructors, Julian?
Constructors are fantastic.
Indeed, they are. Uh, and so the constructor was essentially solving a problem in GameMaker. We went from heavyweight objects to lightweight objects. They expanded over time. Originally, that was the initial thing, but it was what we got for doing that, and why did we do that? So so why did we do that? Come on, Julian.
Well, the idea was previously, pre 2.3, the dark times, we had object-oriented principles in GameMaker that was like the object. If you hear the object and don't think object-oriented programming, quite frankly, there's something wrong with you. Um, the idea is that an object in GameMaker is still like it exists in some sort of pipeline, and if your object has a collision mask, and even though it might not collide with anything ever, because why would it? It's your manager object, but it has a sprite, so it has a collision mask. It's still being checked against like all other objects if it can collide and everything. So the idea is that all objects have some sort of overhead when you use them. And that overhead causes, when you have a lot of objects, it causes them to like slowly eat away at your frames per second, which optimization is another topic. We can discuss it another date. But basically, the idea was that these objects are heavyweight objects because whenever you use them, they come with that sort of overhead, like, and you can't do anything about it because it's in engine and you can't optimize anything out of it.
That's true.
Because it's GameMaker, not your code. And the idea was to fix it. It was to add lightweight objects, and that's a term to throw around cautiously because nothing really is lightweight by default. It's the code making it lightweight or your code making it heavyweight. But again,
Lightweight by
GameMaker
comparison.
GameMaker being GameMaker, lightweight objects kind of were born, if you want to say that. And lightweight objects are basically the idea that you have something called a struct, and a struct is just a collection of data, to put it simply. Like when you have an object, you can define a variable for it, like player speed. And with the struct, you can do practically the same, but now it doesn't have the create even. It doesn't have the sprite. It doesn't have whatever. It just exists, and you can access its data.
It's basically just an empty space that you can put whatever you want into it, so it doesn't come with all the additional baggage.
Yes, it's basically an object that is completely empty, like entirely empty now. And these objects, like these structs, are further divided into two different kinds, if you want to think of it that way. The I call them static structs. You define them like in code, and it doesn't have something called a constructor. And these are perfectly fine to use, and they're fun to use too. But the problem with it is that you can't use them very flexibly, and they're just collections of data. They're nothing more. You can put a function in there, you can put whatever in there, but they can't do a lot. And that's why a thing called the constructor exists, which is basically for all practical purposes the same thing as a class in other object-oriented programming languages, or like, well, again, a lightweight object. So the constructor is basically the create event of a struct, and the idea is that in constructor struct, if you can refer to that way, you can
I do.
create an instance. Yeah, you can create an instance of that struct, which is basically the same as creating an instance of an object. And you can change things about that instance, and that instance can do things, and that instance is, well, for practical purposes, again, a lightweight object.
Exactly, and here's where it kind of gets interesting because as when I was talking to El Digit and kind of trying to explain what the appeal of it is interestingly enough we end up with the question is actually a lot simpler than you might expect, because I would say, like, what's the difference between making an O, why do you make an O player object and an O enemy object, and we end up with that very simple back to formula encapsulation. We want to keep all the data that's relevant to one thing separate from it, and also now we can tell them apart, right? I have 4 player objects, but this is player 1, this is player 2, that's player 3, this is player 4. And so we're going to take a look at some code here. You've seen me post a couple pictures in chat of something that I've been working on. But I felt like it was a good example of showing ways to kind of encapsulate up data. So something we touched on last time was how you don't have to keep all the data necessarily in one place. Like, where's that data relevant? And in this case, I have my player data struct, and I have a couple convenient features here. Like this is for like an RPG scenario, so you'll see that I've actually created a method to equip things to my player as well as unequip them. Consume will be for when they're using objects. And then I have a bunch of stuff down here. Now, this is all debug code right here, but this is actually what I want to show. Because while having this player data all encapsulated, it seems nice, but you could say something like, well, why don't I just put that on my player object? And the answer is you might. But here's where I do want to show off something that's kind of neat, which is for my inventory, you just go, I have this new inventory right here, and I define a size of 255. Excuse me if you're not familiar with hexadecimal, but I use it all the time. And so we end up with this inventory object. And this is where we really get into encapsulation, because what is an inventory? And that's a fantastic question. What is an inventory? An inventory, it's a way of, we have to answer these questions specifically, but we can look at this object and see what my inventory is. First off, it's an array. So it's actually built on the back of arrays. And it's the ability to add things to it. It's the ability to sort items that are inside of it. Its ability to, actually, that's all part of sorting code, so ignore that. We also have an isFull function. If I were to go into my array right here, which I forgot to bring up, we can see that the array itself also brings some other features to it. We have we have the ability to get indexes, which I don't want to get too much into this. Point is that we we have all these features that make up our inventory. We've said, like, what is an inventory? Okay, well, an inventory isn't just an array. It's also a way of interacting with data within. And ideally, that data that we're working with is going to be easier because of it. Because when I get out here back to my player data, which is the reason why I have that open, is we can see that when it comes to my inventory, I'm not really concerned with how the inventory works, right? The internal structure of the inventory we can see here. Here's the add function. This is what add does. But the player is not concerned with how the inventory works, nor should it be concerned with how the inventory works. And instead, I just say, hey, inventory, add this thing, and we're done. We can also I don't think I have any examples here. This is all done for debugging purposes, so we can sort the inventory, we can equip things, and we create the situation where we've encapsulated not just the state of the inventory, but also what it does. What is an inventory into this little section? Oh, sorry, into this little section. Here's the inventory. Yeah, and we no longer have to be concerned with that on the outside. We can just, well, anyways. I hit a roadblock in my thought process
Yeah,
there.
what I was thinking about is like pre 2.3, there was a very similar problem, I'd say, where you had objects, and objects can obviously execute code and whatever. And I'd often see people say, like, why would I use a script here? And there's a ton of reasons for that. Namely, if you write that inventory code, it's all in one place. When you want to edit it, you can edit it in that place, and you don't have to go into, like, let's say you have an enemy and a player, both have inventories. Now, because you have your inventory class or constructor or struct, we'll just refer to them as classes for now. You have your inventory class, and when you edit it in your inventory class, you edit all the inventories for all players, all enemies, everyone. When you don't have that in your class and instead create the inventory, well, you hard code it for the player. When you want to have an enemy, you first need to copy that code, but when you want to change something, you need to change it for the enemy too, and all that jank.
Oh
And
yes. And yeah, and
the
you
other thing
actually
is,
have reminded me exactly what I was going there for. Is that
great.
is pre 2.3. Uh, GameMaker is very structured, but it's also very global. And so what you might have done is created that function so that you could reuse it. You'd be like, inventory underscore add. And the trick here is that let's say that you have an enemy that has a special inventory. You still want to to interact with it in the same way. But previously, you would have had to write one script that could handle what, 5 inventories, two. It doesn't really matter. The point is it would have had to take into consideration just what kind of inventory it was working with, or you'd have to write a brand new function. And now you have like all these specialized inventory functions, and they're just out in global space. They're not really assigned to that inventory. They're just a convenience function, and that's kind of what global functions should be. Is for convenience. And to get back to our encapsulation conversation, we could essentially take that global function, push it into the actual inventory itself, and then as Julian had just said, when it came time to, let's say I wanted to add a feature to my inventory, I add a feature, and then suddenly that's present among every other object. If I fix a bug, it fixes that bug in every object that uses an inventory. If I want to change how inventories work, as long as I preserve that outward facing methods, I can do that. Like my inventory is based on an array, but if I wanted to change it to be based on a linked list, I would literally have to change one variable, and it would automatically adapt. And that's the power of encapsulation right there. Is by binding everything up into this one package and using that with these outward facing ideas, we can edit code. We can make it much easier to manage large scale complexity, as well as just write code that's more legible overall. I mean, what's more legible? Inventory add parentheses my inventory comma this item, or inventory add item. And well, at least for English speakers, inventory add item is a very natural phrase. You can read that and kind of understand what it's doing. It tells a story. Oh, sorry, I'm adjusting my adjust. All right.
Yeah, and another great thing about encapsulation is that not only is your code becoming more readable, it's also, as we've mentioned, becoming more manageable. And well, encapsulation, since it's an object-oriented programming principle, ties in with the other three very well. That's kind of the point of being one of the core principles. But the idea is that when you have encapsulated code, and since we're not going to talk about inheritance a lot, but inheritance is another very fundamental thing about object-oriented programming. When you have your data in one place and you inherit that data, it's becoming easier to inherit because it's all in one place. So you can override your functions easily. You can change the way that inventory works for that specific enemy very, very easily because all that data is in one place. And another thing is because we talked about it last time with state machines. State machines are very much a form of encapsulation where you have all your data that's relevant to that state in one place. And we had the 15-minute talk on why that is a great idea and why you want to do it in the switch case statement and everything. But the idea is that because everything is one place, you know what's related to it, and you can write code that is we call true, because you know if that enemy is going to use that inventory, it's always only going to execute that code. But when you don't encapsulate your data properly, and like have all that inventory code for all enemies and in one place, which is still encapsulated, you might argue, because it's all the enemy code in one place. It's encapsulated poorly because now you're writing code that isn't related to the other code, because sure, it's all enemies, but if that enemy uses that specific kind of inventory where it says like I'm going to use potions to heal myself, and the other one says like, yeah, I'm going to throw swords I picked up at enemies or whatever. It's sure it's an inventory, but it's very, very different code, and it doesn't belong in the same place.
And you touch on something that's kind of interesting right there. Is if we go back to that global script example of like inventory add, the other thing is let's say you did want to use a custom inventory and you found some clever little workaround and you're like, ooh, I can hack this so that the enemy will use it special. And then later on you're like, oh, there's a bug in the inventory add function. And you're like, okay, I got to fix that. Oh, suddenly you've broken something somewhere else because, well, they were very Julian said weakly encapsulated, but I would actually say that they were weakly related. They were more circumstantially correlated than anything, because you have this function that, yes, it will operate on inventories, but only if you can agree on what exactly kind of data it'll accept. And that's why, global functions, like a lot of my global functions are things like string explode, and it's literally designed to work on strings. But when you talk about
Mm.
something more complicated like an inventory, or I don't know, a jet turbine engine, like suddenly can you really build some global thing and agree that this is. So no, we say this is a jet turbine, and then we create our internal methods to essentially enforce how the user can interact with it. Game Maker's not good at protecting that boundary. A lot of people will complain about the lack of privatization in GML, and I will touch on this briefly just because we are talking about encapsulation. A lot of really strongly object-oriented languages are going to allow for privatization and protection of variables, which essentially means that they can't be accessed externally. Like right now, you can say O player X, right? O player dot X, and that works because everything is accessible. It's none of it's private. Privatization would be like, for example, in my inventory, if I were to hide the actual array from the external user, say like, no, you can't touch that, you can't get at it. The only way that you can interact with it is through the methods I wrote. So GameMaker doesn't really allow for that, but that just kind of means that you need to be mindful of how you access your data. And the fact of the matter is you can violate the heck out of software no matter what you code in. It really takes a self what's the word I want to restraint to prevent from doing that. And I would say that structures and encapsulation helps us do this, because while you can violate things more easily, it also makes it a little bit more clear. Like if you're violating it, you can ask yourself like, hey, can I do this in a standardized way which prevents me from having to maybe expose this boundary as I am doing.
Yes, and I kind of forgot where I was going with what I was going with earlier. But another thing is, you mentioned the global space. One thing you hear, it's usually said to go against object-oriented programming. It's object-oriented programming backwards, just spells poo. And the thing is, if you do object-oriented programming backwards, or wrong for that matter, it's going to be messy. And if you have everything in the global namespace, sure, that's encapsulated. But if you're being real, that's not what encapsulation means, because encapsulation means you keep relevant code in the same space. It doesn't mean keep all your code in the same space because it's all your code.
The
And
program is a form of encapsulation, but let's not put everything at the top.
exactly, that's just like doing it for the hell of it. So you shouldn't do it.
Doing it for
And
the
the thing
lulz.
is, what I tend to do when I write very encapsulated code is that uh, I have calls that are 100 plus symbols long. So I have like this huge string, and it's just something like scene.processor.attack. Whatever. And then it's just one function. That's poor by design. Um, it shouldn't be that way. And that's something like with all things, you can do encapsulation, not at all. You have everything in the global namespace, like everything does the same thing. You have one object that draws all enemies, handles all logic, and it's all global. That's bad. But if you do everything while in its own space, where you have everything segregated to the most extent, that's bad too. So encapsulation
You can
isn't
over
about
encapsulate.
exactly. Encapsulation isn't about having everything that can be encapsulated and encapsulated, because that's not the point of it. The point of an encapsulation is that you keep things that are relevant to each other in the same space, so they're easy to access for the things they're relevant for.
Yes. And it should be noted, and I guess we probably should have said this at the start, but the encapsulation, what does that mean? Capsule. Well, that means we have an
Um,
inside and we have an outside. And so, you want to put everything that's relevant on the inside, but the reason why we use methods, and so, and you can just access variables directly, but the reason you would add methods is to sort of, because in GML you can't necessarily enforce it, but to hint at how it might be used. Instead of saying like, "Hey, you need to edit this array directly," in my case, I can just go inventory add, and you end up with a really good result. It hides that complexity. Now, I do want to say this, and I always love saying this, and I feel like it doesn't get said enough, but there's this belief I run into every once in a while where people think that code doesn't exist. Like if you don't write it, it won't exist. And that is true, but it's weird that if you don't have the code that people think it will run. They have this idea where they're like, "Oh, well, I wrote it this way because I thought it would be faster." And it's like, "Well, you need all the code for something to run." And so encapsulation, functions are just a form of encapsulation. All that code has to run to make an idea work, but we've just hidden it away so that we can just call this function. The functions aren't faster. They're not, well, in some cases, but anyways, they're not faster by design. They're not naturally superior to running code individually. But what they do is they consolidate it into a nice little chunk that we can then reuse, but also that hopefully we can kind of understand and reason about our program a little bit better, because instead of 40 lines of memory addresses and changing values, instead you just have oh, the player opened a chest.
Yes, and I like that you mentioned that, because encapsulation is really about just making your life easier. And if you're not into that, then I'm sorry, encapsulation isn't for you.
Yes, and we mentioned this last time as well. Your code should work for you, and encapsulation is a great way to make it work for you. In fact, the comment that I made to El Digin, and hopefully it rubbed off on him, is you may not understand the necessity of it now, but the funny part is once you do it for the very first time, I don't think you'll ever go back. You'll never see a reason to return to the old way of doing things. And it is kind of funny when people will say things like, "Is OOP dead?" And you have to be like, "Is encapsulation dead? What are you talking about right now?" It's just as you can over encapsulate, you can over object orient. Like sometimes it doesn't need to be an object; it can just be code. That's why we have global. That's why we have global functions. I mean, it can be okay. The encapsulation is just another tool that you have to bundle up ideas. And Julian had said ideas, or sorry, we talked about objects, and so I'm going to cover this as kind of maybe our last little bit. Is what is an object? An object encapsulates variables, but it also encapsulates events. And that's what makes it kind of a heavyweight object, is just by creating it, just by virtue of it existing, it comes with all of this baggage. It has a physics engine attached to it, it has collision events attached to it, it has events attached to it. And while Game Maker Studio does optimize a lot of that out, I could use an object to build an inventory. I definitely could. The only issue is that it comes with a lot of baggage that I might not necessarily need. Whereas with the struct, I can start from scratch and I can say, okay, this is what my object is. This is what a chair is. It's not a draw event. It's not a, or I guess I'm going to walk that back and say something more abstract, like, I don't know, health. Let's just say health was a struct. What is health? Well, okay, maybe it's an add function and it's a remove function and it's a check function and it's some value. And the interesting thing about that is you could write a function that's like is alive, and as long as you use that is alive function, you could completely change your health system later on and you wouldn't have to rewrite any other code, which I think is pretty sweet.
Oh, it is definitely. And one more thing I want to mention about encapsulation is that it's also a great idea to write encapsulated code when you're writing tools for something. Because oftentimes, especially like, well, oftentimes complex tools can get complex.
I
I'm not
believe
sure
you.
if there's a better way to put it, but oftentimes you find yourself writing code that's really difficult to understand. And the big benefit, and we mentioned it earlier, is just you can easily change things, you can easily reuse it. But the other thing is you protect yourself from having to understand the same code over and over again because it's really complex code. you can't change anything about it being complex because you're writing complex code. But you can change the fact that you have to read complex code by having it encapsulated somewhere that makes it easier. Because you mentioned that 40 memory addresses and pointers and whatever, that's difficult to read. But if you just have inventory add, that's easy to read. It's not only easier to read because you speak English and can read English, and inventory.add makes sense from a linguistic standpoint. It's also easier to read because you don't have to understand it every single time you read it.
Yes.
So,
And that'll be my closing thought is just to piggyback off of what you just said, which this isn't necessarily encapsulation specific, but encapsulation definitely helps with it. Kind of like when I was showing my inventory add thing there, is you can write code in a way that is easy to understand and read. Like it doesn't have to look like code. It can look very much like just an idea, and you can read it and say, okay, that's easy to understand. And encapsulation helps with that because since we put everything in its place, we can write slightly more naturalistic ways of interacting with things. And because we've bundled it all up, and we don't need to know what's happening beneath that, as long as that outward facing function is always true and exists, then we can rewrite everything on the inside, and it would be none the wiser. Was that your closing thought, or do you want to put in another one?
oh no, I want to put it in another
Do it.
one. What helped me understand encapsulation a lot better is that I created kind of layers of, let's call it access, in my game. Because I have these different levels of what code is allowed to touch what. And there's like this very global area that's called a scene. And that scene has, for example, a processor that handles all the battle logic. And the processor is only allowed to touch other things in the scene through the scene itself. So it has to reach up. And there's only one way to reach up. It's only through the scene object. You can't reach up anywhere else, and everything else can only reach down. So I have my processor, and the processor has something called an action queue, and the action queue can access all its actions. But the actions shouldn't be able to access the processor again, because that's not the point of the action. The actions, if they really need to, and that's why it's kind of like a long thing by design, what I mentioned earlier, is that I have to go through the scene, then processor, then action queue, because that makes you think about, well, maybe there's a better way to write this, because I don't want to reach up all the way again and write a very long line of code.
When you end up with this long line of code, you go, did I screw something up?
Yes, exactly. And that's why I kind of write wrapper functions for things where I'm like, okay, I have this, and it's not supposed to do this, but I might want to do this. So I'm going to write something that's like, it tells me you don't want to do this, because usually I find a better way of solving it, because I created encapsulated code, and everything that belongs in there already, and I want to access it. I'm in that space already, so I'm doing something wrong. But like creating those levels of what's allowed to access really helps with encapsulation.
Yeah, to touch on my inventory example, the inventory doesn't reach back and touch the player, because why would it? But the player reaches in and touches the inventory because the player needs to interact with the inventory. So yes, 100%, you can get that nice little, you're like, what am I doing? Why does this look so weird? Why is it so hard? Well, maybe it's because I've done something weird. Anyways, I feel like that's it's our podcast on encapsulation for today. I've been Hyomoto. I hope you enjoyed it.
And I've been Julian, and I hope you enjoyed it too.
And until next time, keep on coding.